Hi everyone, we're going to find the dimensions of a rectangle with area 1,000 meters squared and whose perimeter is as small as possible. Therefore, we want to minimize the perimeter. We're going to do the first derivative test for absolute extreme values, and let's look at the dimensions of a rectangle are x and y, and therefore its area would be x. Let's see, area equals x times y. And that's going to equal 1,000 meters squared. Now, if we solve for y, we get y equals 1,000 divided by x. We know our perimeter formula is 2x plus 2y. So that's going to equal 2x plus 2 times y. So this is going to be 2,000 up on top there in the numerator. So to minimize it, for x has to be positive. To minimize it, we're going to take the derivative of p prime of x. So remember, this is just 2,000. So derivative of 2x is 2 minus, and then again to do the derivative of 2,000x to negative 1. That's negative 2,000 x to the negative 2, which is going to be 2,000 divided by x squared. Now, what I can do is go ahead and rewrite this as pull out the 2, and we're going to also put an x squared here in the denominator, so that would be an x squared here, just so we have the same denominator. So it's 2 divided by x squared, and you're going to have x squared minus 1,000 to factor that out. All right. Now, to solve for your critical number, we're going to set this equal to 0. So the only one that this satisfies with, you have x squared minus 1,000 equals 0. So you have x squared equals 1,000. So x equals square root of 1,000. Remember, we can't have negatives. Okay, x has to be positive. All right. So that's the only critical number. Our critical number is x equals square root of 1,000, which can be written as 10 square root of 10, if that helps. All right. So now I'm going to go ahead and take the second derivative of x, and our first derivative was 2 minus 2,000 divided by x squared. So our second derivative is just going to be 4,000 divided by x cubed. So I just took the derivative of that. All right, and x, we want this to be positive. So this is positive. For any value you put that x is greater than 0 is going to be positive. That means our perimeter is concave upward throughout its domain. All right. So that means this is a good number. That's going to be your minimum value. And what we want to do is find the absolute minimum value by evaluating p of square root of 1,000. So you just plug it in our original formula, which was, let's see, p of x equals 2x plus 2,000 divided by x. When you plug that in, you're going to get 4 square root of 1,000. So that's your absolute minimum value, and therefore the dimensions of the rectangle with a minimum perimeter are x equals y equals square root of 1,000, and that's going to be also 10 square root of 10, which is the absolute minimum. The rectangle is a square. And that's it. Thank you. Have a nice day. Bye-bye.